Welcome to Algebra 2. This is section 8-4, rational expressions. So in this section, our objective is to simplify rational expressions and to multiply and divide rational expressions together. And what you need to know is that you can use much of what you know about multiplying, dividing, and simplifying fractions to do the same thing with rational exponents. So what do we mean by that? So reducing fractions. Let's take a real basic example here and say we have a fraction like 6 over 8. Well, you should know that you can't leave it like that, or you shouldn't leave it like that, and it reduces to an equivalent expression 3 over 4. Let's think about what you're really doing here. Basically, what you're doing is you're factoring out a common factor in both the numerator and the denominator. So you're changing this 2, or the 6, to 2 times 3. You're changing the 8 to 2 times 4, and then you're canceling out these common factors to give us our expression. Okay, so that's what we do when we reduce fractions. We can take the same idea and reduce rational expressions to their simplest form. All right, and this is when the numerator and the denominator are polynomials that have no common factors. These two are in the simplest form because there's nothing to cancel there. And just looking at this, we can't necessarily tell if there's anything to cancel, but if we factor the top to x plus 2, x plus 1 over x plus 3, none of these are common factors. So nothing can cancel. These three are not in simplest form because this has an x in common, this has an x minus 3 in common, and again, it's tough to tell whether or not that second one or that last one has a common factor. So what you want to do is factor it. So the top factors of 6 that subtract to -1. So that's going to be x minus 3, x plus 2, over factors of 2 that subtract to a positive 1, x plus 1, and x minus 1, x plus 2. Yeah, there we go. Okay, so you can see now that these two do have a common factor and can simplify. Okay, so that's what we're going to start with to put a rational expression into its simplest form. And we're going to do this by dividing out common factors in the numerator and denominator. Factoring the numerator and the denominator will help you find the common factors. And exactly here's what we just did in the last little example. One thing to mention is that you have to exclude -2 from the domain. If you are just looking at this expression, you say, okay, this has a discontinuity at 1. It's a vertical asymptote. But you have to include this one because you canceled it out. It is a hole in the function. All right. So when we are writing these expressions, okay, it is typical to list all of the x values that are excluded from the domain. So the simplified answer would be, right, this expression x minus 3, x minus 1, comma, x is not equal to anything that made the denominator equal to 0 at any point in this entire problem. So that's 1 and -2. Okay? And it's a good habit to get into not just write the -2, but to actually write both of the excluded values, the 1 and the -2, the one that's still there and the one that you canceled out. So let's try our first example. Okay? So here is a rational expression. Let's simplify it and then state the restrictions on the variable. So the best thing to do is don't do this. That's not a thing. Okay? So the best thing to do is to factor it and then cancel. So we factor the top. Factors of 10 that add to 7 are x plus 5, x plus 2 over factors of 10 that subtract to 3 is x minus 5, x plus 2. Okay? So now we see that we do have a common factor. They cancel out, and my expression is x plus 5 over x minus 5. Again, these do not cancel. They're not exactly the same. Comma, x cannot be equal to anything that makes the denominator equal to 0. Well, that's 5, a vertical asymptote, and negative 2, a hole in the function. Okay? And again, this one is more important because it's not evident from your final answer. If you're just trying to graph this function, right, you need to include that it had a hole in the function. Let's try a few more of these. Nice monomial. We don't have to go too crazy here. So we just divide everything and we get a 24 divided by negative 6. That's a negative 4. X over y. Okay, comma, well, x can't be equal to 0 because then that will make the denominator equal to 0. And y can't be equal to 0 because that would make the denominator equal to 0. And typically, we're going to stick with single variable expressions here instead of terms like this. Part B is just like the one we did up at the top, where we're going to factor this. So factors of 8 that subtract to 2, that's x plus 4, x minus 2, and factors of 6 that add to negative 5, x minus 3, and x minus 2. These two cancel out. So my expression is x plus 4 over x minus 3, comma, x is not equal to anything that makes the denominator equal to 0. So that's a 2 and a 3. Okay. Last one here. We can factor out, let's actually factor out a negative 4 to leave me a positive x and a minus 3. So that way it's in the right order. Check that. Yep. Okay. And x squared minus 9 factors in x plus 3, x minus 3. Those cancel out to give me my expression of negative 4 over x plus 3. I'm out of space here, comma, x is not equal to plus or minus 3. Anything that makes the denominator equal to 0. Okay? We can use what we know about simplifying rational expressions when you multiply or divide them. So before we do that, just take a quick second to remember how to multiply fractions. Okay? You could, if you wanted to, well, first you're going to multiply across the top and multiply across the bottom. So you could, if you wanted to, multiply across the top and get 8, multiply across the bottom and get 6, and then factor out a 2 from both of them and get 4 over 3. But I would say the better way to do this is to cancel stuff before you even multiply it together. Right? Anything on the top can cancel with anything on the bottom if it has a common factor. This 2, if you factor out a 2 from here and change this to 4 times 2, can cancel with this 2. And now when I multiply, I don't have to reduce anything. Okay? So that is the better method. Cancel everything first. Anything on the top with a common factor can cancel with anything on the bottom. And then put the expressions together. Kind of like this. So before we start canceling this, I'm going to have to factor it. And of course, remember to state the restrictions after we're done. So let's factor everything and get a nice big expression with all common factors. Factors of 6 that subtract to 1. That's x plus 3, x minus 2 over x minus 5 times difference of two perfect squares. x plus 5, x minus 5, over factors of 3 that add to 4, x plus 3, x plus 1. Okay, now anything that's the same on the top and the bottom can cancel. X plus 3, x plus 3, x minus 5, x minus 5. There's no other x minus 2 or x plus 5 on the bottom, and x plus 1, there's nothing like that on the top. So my answer becomes x minus 2 times x minus 5 over x plus 1. This is multiplication. I know there's nothing else that's going to cancel here. I can see it in the factors. So you don't have to distribute these together to get an answer. You can just leave it like this. But you're not done. You have to state the restrictions of the variable. What is x not allowed to be? Well, I can clearly see here, right? It's not going to be negative 1. But don't forget the 2 that you canceled out. So that means x cannot also equal 5 from this one, or negative 3. So this particular function has 1 vertical asymptote and 2 holes. Okay? If we remember what that means when we reduce these, or when we cancel out those discontinuities. Let's try this one. Again, factor first. Factor out of 2. That leaves me with x minus 4 over. That is the difference of two perfect squares. So that is x plus 4, x minus 4. Let's just wait a second. We'll get them all done, and then we'll start canceling. Factors of 4 that add to 5, x plus 4, x plus 1, and factors of 16 that add to 8, 4 and 4. So x plus 4, x plus 4. Okay, so one of these cancels with one of these. This one cancels with this one. And that's it. So we have 2 times x plus 1 multiply across the top and multiply across the bottom. X minus 4, x plus 4, comma, x cannot be equal. And if you have something that canceled out that's still already there, that's fine. Okay. So x cannot be equal to anything that made the denominator equal to 0, and it's just plus or minus 4 in this case. Right? You don't have to write 4 twice. There's no, we don't have to do anything crazy with a multiplicity or anything like that. We're just saying that this function is undefined at 4. Okay. All right. What about division? Hopefully you remember that to divide two fractions, we multiply by the reciprocal. And then we multiply across the top and then multiply across the bottom. Okay. So we're going to take the same idea. To divide rational expressions, we're going to multiply by the reciprocal of the divisor, just like we did with rational numbers. The only thing you have to remember here is that x cannot be equal to anything that was ever part of the denominator. So that means in this question, x squared minus 1 is part of the denominator now, and then this will be part of the denominator in a few seconds. So anything in this side right here is a restriction on the variable. Anything that sets the numerator or denominator equal to 0. All right, so first, I don't like that, so let's factor out a negative, and that turns into x minus 2. Keep it in the same form as everything else. This would be x plus 1 times x plus 1. I could write x plus 1 squared, better. Let's just change it to multiplication right now. That means this goes up to the top, so that's x plus 1, x minus 1, over factors of 10 that subtract to 3 is x plus 5 and x minus 2. Okay, now remember, this used to be in the denominator. This is in the denominator now. Okay, let's cancel. And these are in the denominator now, so this cancels with this, okay? Um, just because it went to the numerator before doesn't matter when we cancel. It only matters when we talk about the restrictions on the variable. One of these x plus 1s cancels with one of these, and so our answer is a negative x minus 1 over x plus 1 times x plus 5. Okay, comma, x cannot be equal to anything that made the denominator equal to 0. So that's a 1 right there, or sorry, a negative 1 right there, a negative 5, a positive 2, but also a positive 1 because that used to be in the denominator. So the excluded values, there's actually 4 of them, is plus or minus 1, negative 5, and 2. Let's try another. One more. Okay, so let's factor it. So that would be x plus 4, x plus 1, factors of 12. That's subtracting give you 1. So that's x plus 4, x minus 3, times, I'm just going to flip these over. I can factor out a 2x from this, and that leaves me with x minus 3 over x plus 1, x minus 1. Okay, x minus 3 cancels with x minus 3, plus 4, plus 4, plus 1, plus 1. So we have 2x over x minus 1, comma, x cannot be equal to, well, negative 4 there, 3 there, plus negative 1 there, positive 1 there, so that's plus or minus 1. And anything that was in this part as well. So the 3 we already have, but this x also we can't have a 0, right? Because if we plug in 0 into the original expression, we get a 0 in the denominator. Right? Without doing the calculation, what's the greatest number of restrictions the quotient can have? Well, could have 2 for this one, 2 for this one, and 2 for this one. So it could have 6 restrictions. And we almost had all 6 right here, but we only had 5 because these 2 cancel. All right, let's finish with a word problem. And mostly the trick about this problem is we're going to use rational expressions to solve a problem. The trick about this is just being able to write the 2 rational equations. So your community is building a park. It wants to fence in a play space for toddlers. It wants the maximum area for a given amount of fencing. Which shape, a square or a circle, provides the most efficient use of fencing? Well, if we want to find the most efficient use of fencing, if we divide the area by the perimeter, right? If we divide the area by the perimeter, we're figuring out how much fence we're using to close in a certain amount of area. Okay, so we have 2 kinds of things. We have a square, right? The area of a square is the side squared, and the perimeter of a square is 4 times the side. Okay, well, if we take the area divided by the perimeter, like we have right there, we have s squared over 4s. Oh, sorry, s squared over the perimeter. Okay, let's come back to that for a second. Okay, let's do the circle. Okay, so the circle area of the circle is pi r squared. Perimeter of a circle, which is also called the circumference, is going to be 2 pi r. Okay, so let's make my little ratio. Area divided by perimeter is going to be pi r squared over p as well. Now we're almost to a place where we can compare both of these. If they only just had the same variables, we could compare them both, and we can do that by uh, just putting p. And we can do this here by solving this for p, and we can get a little substitution, right, that we can get that s is equal to p over 4. So because that's true, we have p over 4 squared over p. So that's p squared over 16 over p. And we now have a rational expression, something over something else. We just have a simple division here. To divide a fraction by a fraction, multiply by the reciprocal. So we're going to multiply by 1 over p. This one cancels with this one. And my expression is p over 16. Okay, how did that help me? It didn't yet, but let's do the same thing over here. Let's, if we, just change this so it's the same variable. I know it means circumference, but we can call parameter. We can solve for p. Or solve for r, so we have it in terms of p. So we have that p over 2 pi is equal to r. Replace it in this expression, that pi times p over 2 pi squared over p. All right. This now turns to pi times p squared over 4 pi squared over p. Now we can start canceling right now. Cancel one of these with one of these. Multiply it by the reciprocal. And cancel this with this. And so what we're really doing now, when we simplify this expression, is we have p over 4 pi compared to p over 16. Well, pi is 3.14, so this is p over 12. This is p over 16. That is a bigger number, because if you divide by a smaller number, you're getting a bigger number. So the answer to this question is that the circular fence is a more efficient use of fencing. But if you can visualize a park with a circle fence, it is a more efficient use of fencing, but a less efficient use of space. So this was kind of a silly problem. Hopefully you followed along, but the point of this section is to be able to simplify the rational expressions, state the restrictions on the variables, multiply and divide, factor first, state the restrictions. Anything that was in the denominator ever is a restriction on the variable. And that was 8.4, rational expression.